Hi everyone, I'm Zohreh and I hope you're doing great. In this video, I'm gonna teach you Holiday Physics. It is one of the most important book in physics. I will talk about first chapter, which is about measurement. I will discuss base quantities and units, the unit system, scientific notation, and significant figure and decimal places. If you are interested in physics, then you can join and enjoy.
Welcome to our physics holiday book adventure. Today, we'll explore the fascinating world of measurements and their importance in understanding the universe. Measurements are the foundation of physics. They allow us to quantify and describe the physical world around us. From the tiniest particles to the vastness of space, everything can be measured. Base quantities and units. Science and engineering are based on measurements and comparison. Thus, we need rules about how things are measured and compared, and we need experiments to establish the units for those measurements and comparisons. We can define a unit and its standard in any way we care to. However, the important thing is to do so in such a way that scientists around the world will agree that our definitions are both sensible and practical. Base quantities such as mass, time, and length. The unit system, the International System of Units, abbreviated SI from its French name and popularly known as the metric system. General Conference on Weights and Measures picked 7 quantities as base quantities. Many SI drive units are defined in terms of these base units. The SI unit for power, called the watt or W, is defined in terms of the base units for mass, length, and time. For example, 1 watt is equal 1 W or is equal 1 kilogram times meter squared over second cube. Scientific notation to express the very large and very small quantities we often run into physics. We use scientific notation which employs power of 10. For example, the first number is very large. We can write it in scientific notation as 3.56 times 10 to the power 9. Or the second number is very small. We can write this as 4.92 times 10 to the power 7. For the first one, we can only count the zeros. We consider one digit, the first one, 3.56, and then after 3, we count the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 digits after 3. Then the power of 10 will be 9. Or for the second example, we write the first significant digit, which is 4, 4.92. Then we need to count the digit before that. 4 is the first one, and then we count the 0. 1, 2, 3, 4, 5, 6, 7. We have 7 number before the point. Then the power of 10 will be 7. Scientific notation on computers sometimes takes on an even briefer look, as in 3.56 E9 and 4.92 E-7, where E stands for exponent of 10. Further convenience, when dealing with very large or very small measurements, we use the prefixes listed in table 1, 2. Here you can see the prefix and the symbol. As an example, 1.27 times 10 to the 9 watts, we can write this as 1.27. As you can see in the table, 10 to the power of 9, it is giga or G. Then here we can write 1.27 gigawatt instead of 10 to the power 9, or we can only write 1.27 GW using chain link conversions. We often need to change the units in which a physical quantity is expressed. We do so by a method called chain link conversion. In this method, we multiply the original measurements by a conversion factor. A conversion factor is a ratio of units that is equal to unity. For example, 1 minute is equal 60 seconds. Then 1 minute over 60 seconds will be equal to 1. And 60 seconds over 1 minute is also equal to 1. Thus, the ratios 1 minute over 60 seconds and 60 seconds over 1 minute can be used as conversion factor. Here, I brought an example. We want to change 2 minutes to second. We have 2 minutes times 1. 1 is the conversion factor. Instead of 1, we use the conversion factor, and here we should pay attention that we need to cancel minutes. Then we put minutes in the denominator, and 1 minute is equal 60 seconds. We put 60 seconds in numerator. After that, we cancel the minutes, and 2 times 60 seconds will be 120 seconds. Significant figures and decimal places. Suppose that you work out a problem in which each value consists of 2 digits. Those digits are called significant figures. Be careful. Don't confuse significant figures with decimal places. Consider the length 35.6 millimeter here, 3.56 meter, and 0.00356 meter. They all have 3 significant figures: 1, 2, 3, 1, 2, 3, and 1, 2, 3. Significant figure is the digit, the significant digit, but they have 1, 2, and 1, 2, 3, 4, 5 decimal places. Be careful about significant figures and decimal places. And that concludes our journey through the world of measurements. Remember, understanding and mastering the art of measurements is essential for any aspiring physicist. Stay curious and keep exploring.